Again, warm-up number 3. Number 1 says copy the lesson and home play of the day. You will do this every day. Number 2, find the sum, difference, product, and quotient of negative 18 and 23. Number 3, find the sum, difference, and product and quotient of negative 7.5 and 2.3. See how you do with your decimals. And number 4, get a paper ready for Cornell notes. So you're going to get, once you're done with your warm-up, set up your Cornell notes like this, and then we're going to leave that prayer model for a little bit, and then we're going to start the notes in the back as soon as we get there. So as you're working on the warm-up, I'm going to take attendance. So when I call your name, make sure you say here, raise your hand so I know where you're seated. All right? All right. Get this show on the road. So I'm going to use for number 2, the sum for blue. I'm going to use blue for the sum. Danny, get us started. What is the sum for number 2, negative 18 and 23? 5. Hands if you got that. That is correct. Next, we're going with the difference. Difference. I'm going to use red for the difference. Difference of negative 18 and 23. Pass someone, Danny. Negative 41. That is correct. Make corrections, please. All right. Next. Oh, sorry. Forgot to let it go. Let it go. No. All right. In green, I'm going to use, whoa. Sorry. Green, I'm going to use for the product. Pass someone, please. Negative what? No, just say it out loud. I couldn't hear. 5 what? 554. Hands if you got that. Looks about right. Let me double check. 23 times 18. 8 times 3, that's 24. I got 2. 16 plus 2, that's 18. 23. This is 4. 11. 4. So this is 414, and it's a negative. Negative 414. Hands if you got that. All right, not bad. And last but not least, I'm going to use black for the quotient. The quotient. Pass someone. Martin, what'd you get for the quotient? $72. 0.70. Oh, 0.82. Okay. Hands if you got that. Okay, let me go slow. I think it's me that I'm missing the information. Negative 0.732. 782. Okay. 782. Believe it or not, guys, that AC is so loud. But I love it because it's really cold. You know? Negative 7.82. Hands if you got that. All right, let me double check just to make sure. We got 18 divided by 23, Michael Jordan. You add a decimal and a 0. He said it was 7. Let's see. 7 times 3 is 21. We got 2. 7 times 2, 14 and 2, that's 16. Subtract. That gives us 19. Bring down a 0. Then it was 8. Let's see. 8 times 3, that's 24. We got 2. 8 times 2, 16 plus 2, that's 18. And that gives us a 6. Bring down another 0. And then that fits in there twice. Well, I'll take that. Let's go. Yeah, and it's a negative. All right. So let's get to the interesting one. Negative 7.5 and positive 2.3. I only want the quotients. Check with your neighbor, see what they got for the quotient on that one. All right, let's pass to someone. Pass to someone. Okay, let me start all over. You got negative what? 3.26. Oh, who got a negative on that one? Okay. We got negative 3.26. All right, let me double check. So this is 7.5 divided by 2.3. So I like to get, let's see. Does it fit into 7? Yes, 3 times. So this is 6.9. Subtract, that is 6. Add a 0. So this is 3.2. Yeah, I'll take negative 3.2. And if you got something like that, yeah, all right. All right, we'll stop right there. Now, your Cornell notes, did everybody set up your Freyer model like this? And so that we can write the objective down here, yes? All right. If not, I'll give you some time to set up your page. Once again, draw a line down like so, line across like this. The objective is going to go there, your Freyer model right there, okay? Now, today we are moving on with the lesson. Yesterday we just got close to. I just wanted some practice with some of the home plate. I'll give you some time to set up your page a little bit more, but what is written right after the warm-up? Tell your neighbor, what do we write right after the warm-up? Yeah, here's the agenda. Write that down, please. Agenda for today, we got warm-up number 3, which is already done. We are going to get into number sets and expressions. And today we're having 6 problems for simplifying expressions. And if you notice, the word expression is coming up a lot, so today we're going to be focusing on that. So I'll give you some time to copy that. All right, so warm-up number 3, we just finished. We're getting into number sets and expressions, and tonight's home plate, only 6 problems. So let's look at copy the Nearpod code so that in case you missed some of the notes for today, the slides are going to be in there. You just forward the slide to whatever you missed. So the code is NSHL5. Just write it somewhere in the corner so that you have it, and you can go straight to it when you get home. NSHL5. NSHL5. Okay? So, once again, materials. Make sure you get your materials as soon as possible. If you need to, like, wash cars, clean the house, or sell some cans, whatever you need to do so, please. And just a side note, I remember I started working since I was in elementary. I think I was in the summer of 4th grade to 5th grade. I went to get a job at a farm. They needed like just someone to help. And then on the weekends, I used to shoe shine. Have you guys seen the shoe shine people? But I had a little box that I carried with me and went down to the downtown area, and then just at first I was a little shy, especially like being that I was working for people I didn't know, so it was kind of weird, but it was cool. All right, so once again, get your materials, please. Previous home play, problem number 1. Did everybody finish problem number 1? I want you to go to the last one and share with your neighbors, see what they got for the last one of those. Let's see what they got. Just to make sure we're on the same page, here we go. I'm going to go through the entire process that my noodle goes through so you can see what I'm thinking. So here we go. If you struggled with this one or these kind, I'm going to go step by step. This is what my noodle does first. Whenever I have an expression like this, the first thing I do is scan it to see if there's any subtraction in between terms. So I go and I see that there's a subtraction right here. So that tells me that I need to change the sign of that term. So what I do, I circle that together. That becomes a negative 7m. And in front of it, I'm going to place a plus sign. So now I'm going to have 1 plus that. And then everything else can follow after that because there is no other negative sign. So I'm going to erase these, and I'm going to use this and continue on over here. So with that said, I like to start from left to right, so I'm going to start first with my constant. I have a 1. Are there any 0 pairs for that 1? No, so I scan that one. I'm going to combine it with the other ones. I have a 5 here and a negative 6 here. So what is 1 plus 5? 6 minus 6? 0. They cancel. All right. So far, so good. Next, I go to my next term. My next term is 7m. Is there another m? Yes, right here. So now I have negative 7 and positive 9. They're opposites. The smallest one is this one. Can 7 of these cancel 7 of those? Yes, and that leaves me with 2m. Next, I'm going now to the x squared. X squared. Do we have another x squared? Yes. All right. Are they opposite signs? Yes. So the smallest one is this one. Can 2 of these cancel 2 of those? Yes. So that leaves me with negative 6x squared. Anything left? Yes. The 10a and the 1a. So the total is 11a because they're the same sign. However, standard form. What does that mean, Mr. Q? From highest degree to lowest degree, this should be like a little review for you guys from Algebra 1. That means the one with the highest exponent and then going to the lowest. So I'm going to start with this one, negative 6x squared. What is the exponent on the m? 1. How about on the a? 1. So they're both the same degree. So which one goes first, Mr. Q? In alphabetical order. I'm going to start with 11a, and I'm going to finish with 2m, and we are done. And have you got something like that? All right. Yeah. Okay. So once again, we're going to get there. It just requires a little bit more practice. Okay. So for tonight, here's the home plate for tonight. Only 6 problems. Copy these, please. All right, so 6 problems, just extra practice of what you did last night. Now, some students were asking me in the previous class that they were insecure in regards to or unsure where they're going to be turning in their home plate. So the reason that I haven't gotten the home plate back yet is because I was setting up my computers, as you just noticed. But by tomorrow, I'm going to have my Canvas published. Like that, you guys are going to start giving me your work, so like that we can start getting our home play in and make sure we don't fall behind. So hold on to it for right now, and when I ask you and I pick it up, then that we're going to go from there. Okay? And I'll give you more instructions in regards to electronically how we're going to be turning in stuff here in class. Okay? So for right now, just keep it. So that's for tonight. So where did we leave off yesterday? Once again, if you didn't finish copying, you have the Nearpod code where you can go on Nearpod and copy the rest. Yesterday, we started with this objective. Is that correct? So our objective for today, I can simplify algebraic expressions. I can simplify algebraic expressions. Where does that go? On the bottom left of your Cornell notes. Yes, so write that in there if you haven't. Bottom left, I can simplify algebraic expressions. I can simplify algebraic expressions. So let me just make sure everybody's on the same page. Here's your paper. You drew a line down like so, one across, and your objective goes right there. Yes? From there, you set up a fair model over here with a rectangle in the middle. And what goes in the middle? Well, the main idea. What is it? Algebraic expressions. It goes right there. Okay? Now, I do want to clarify algebraic expressions in a little bit, but I do want us to take a step back and get us to that place. Okay? So, before we get into the actual part of algebraic expressions, I do want us to take you, I'm going to take you back to your history with numbers, if you want to call it, okay? So I want you to turn your paper over or go to the next blank sheet, and I want you to draw this table, please. Draw that table. How many lines? This is about, I don't know, about 7 lines down the whole table. Okay, anywhere on your paper, that's fine. So 7 lines down. This is probably the width of the page, that's fine. So then 7 lines down, and then at the bottom make this little green rectangle over here. But on the left side, you're going to label that real numbers, and on the right side, imaginary numbers. You're like, what? Oh yeah, this is the year. This is the year of the imaginary numbers. Give you some time for that. So, I'm taking you back in time to when you first started with numbers. Right? This is your whole history with numbers, especially those of you that love mathematics. Right? All right, so here we go. When you first started with your career in education, you started with numbers, okay? So which kind of numbers? Well, they're called real because you use them somehow. So I'm going to start in that section. So writing utensils down, look up to the screen, please. I'll let you write stuff down afterwards. Just pay attention just to take you through, just to make sure you are on the same page. Real numbers are broken down into 2 different sets, but they're all real numbers. We have rational numbers and irrational numbers. You're like, oh snap, I think I remember something of that. Rational numbers are basically counting numbers, which is, I don't know if you remember when you used to race when you were in kinder to the swings. Oh, race you to see who goes higher, right? You didn't start with, oh, -1, right? No, you started with 1, 2. That's why they're called what? Counting numbers, also known as natural numbers. Okay. From there, you got further into elementary, which was maybe 3rd and 4th grade. And then they introduced what we call the number 0, and now they were whole numbers. Whole numbers included all the counting numbers, including 0. So counting numbers, 1, 2, 3, 4, all the way to infinity. Whole numbers, same, but including 0. Then, of course, you got to 5th, 6th, and 7th grade and on. And here comes your favorite, right? What are they called? Integers. You're like, what? Which are whole numbers, including their opposites. So all the negatives and positives. You're like, oh, yeah, I remember these, Mr. Q. Yes. So we know what these are. We've been using them since we were in kinder or before that. What are irrational? Well, rationals comes from the word ratio. That means that these could be written as fractions or decimals. Question, can I write the 3 as a fraction? Yes. 3 over 1. Can I combine numbers to make decimals? Yes. 2 divided by 3 gives you a decimal. So if these could be written as decimal or fractions, what are these? Numbers that cannot be written as decimal or fractions, such as pi, square root of 2, phi, and e. We're going to get more into these kind of numbers this year because these are the easy ones. These are the ones that we need to really focus on. Okay? So for right now, on that column of your real numbers, copy that, please. We can have those as samples. So, rational numbers are any of these numbers, whether counting, whole, integers, that could also be expressed as decimals and fractions. Irrationals cannot be expressed as decimals or fractions. You're like, Mr. Q, isn't pi a decimal? Yeah, but it's a never-ending decimal. All right, so when you got to these numbers, and let me take you back in time again, your teachers gave you an exercise that asked you to place, they would give you a number, they would ask you, place it in the section that it belongs. So here it goes. If I gave you the number, let's see, square root of 16. Square root of 16. So you remember what square root of 16 is, and where does it belong? Where does square root of 16 belong? All right. So, square root of 16. Square root of 16, who said that it was 4? Who said that it was positive 4 and negative 4? You're like, what does that mean, Mr. Q? Yeah, a square root is a number times itself. So what number times itself gives us 16? 4. 4 times 4. What other number times itself gives us positive 16? Negative 4. Negative 4 times negative 4 is 16. So where does this one belong? Integers, yes? Plus and minus. Now, for those of you that went just with a positive, that's fine if you placed it here or here as well. Okay, so in what column? It's a rational. Okay. Now, irrational, for example, square root of 2, can you find square root of 2? It would have to be a decimal with a lot of never ending. So question, does this one belong over here? No. How about square root of 3? Where would that one go? Rational or irrational? Can we find the square root of 3? Once again, it would be decimal and maybe continuing. So that would go where? Over here. And so on and so forth. Okay? All right. Next. From there, check this out. We're good with real numbers. We add the column of imaginary numbers. Imaginary numbers. So that's where I'm going. So writing utensils down, look up to the screen. Here we go. This is going to be our bread and butter for this school year. You need to understand where we're going. We're already done with the easy part, which is the real. Now we're going with imaginary. Mr. Q, why are they called imaginary? Or for those of you that used to watch these when you were a kid, remember this? Right? Imagination. Anyways, that means they are numbers that we don't usually use because there's something that we just imagine that they are there. So check this out. On this column, I want you to write this number down, please. Square root of negative 16. All right? So, let me prove a point. Writing utensils down, look up to the screen. We said that square root of 16 is a number times itself to give me that number. Is that correct? So we said this was what? Positive 4 times positive 4 or negative 4 times negative 4, and they both give us 16. Therefore, what number times itself gives us negative 16? Pop it over to your neighbor, please. One number times itself gives us negative 16. Is there such a thing? No. That's why we call these imaginary numbers. Now, before we move on, what's so specific about this one compared to this one? Tell your neighbor how we're going to know that these are imaginary and not these, just by looking at it. Does everybody see the obvious one? Yeah, it's a negative square root. Negative square roots do not exist. They are imaginary. But somehow we're going to put them on paper. All right? Now, check this out. Write your utensils down. Look up to the screen. Let me break this down so you understand what we're looking at. Pay attention, please, if you are to pay attention any time during this lesson. Here it goes. Square root of negative 16 is the same as square root of negative 1 times 16. Do you agree with that? Yes. We can change this to make it look like this. Square root of negative 1 times square root of 16. This is the same as this, which is the same here. So far, so good? All right. You're like, Mr. Q, but don't we know what this is? Yeah, it's a plus minus 4. Is that correct? Yes. So what is the only thing that we cannot find? Square root of negative 1. Is that correct? Well, guess what? This is what we call I. Tell your neighbor what I stands for. Imaginary, yes, I for imaginary. Copy that, please. That goes in the imaginary column. You're like, what just happened? So with that said, since now you know how to, is everybody okay out there? What's going on? Man, you're probably in the language arts class. All right. So does everybody know how to rewrite a negative square root into an imaginary number? Yes. So here we go. On the right of that, I want you to write square root of negative 25. Rewrite that, please. See how you do. All right. All right, here it goes. Just for the sake of practice, you should have written square root of negative 1 times 25, which is square root of negative 1 times square root of 25. What is square root of 25 plus minus 5? And what is square root of negative 1? I. Hands if you got that. All right, let's do one more. To the right, copy this. Square root of negative 81. If you go a little bit faster now. All right, share with your neighbors, see what they got, please. All right, square root of negative 81. What'd you get for that one? Kimberly, what'd you get? Said plus minus 9i. Hands if you got that. That is correct. Last one. Square root of negative 100. I don't want you to do the work. I just want you to write it on the side. By now you should be able to do it in your noodle. Do it in your noodle. Tell your neighbor what you got, please. What is square root of negative 100? Everyone, plus minus what? 10i. All right. So from 1 to 5, how comfortable are you with imaginary numbers? Yeah, 5, yeah, 5 fours, yeah. We're there. So this is where we're going. We started our career with mathematics with real numbers. We're now in Algebra 2. We're moving into imaginary numbers, but we're going to crank it up towards the second semester. And we're going to move on to the third section, which is this section down here. And these are known as complex complex numbers. Complex numbers. Write that in there. And some of you are like, oh, snap, Mr. Q. Oh, yeah. Oh, snap is right. But check this out. I love this little tool that I made. And by the way, I made this one up because it just flows really well. Question. What's on the left side? Real numbers. What's on the right side? Imaginary numbers. Well, guess what? Complex numbers are made up by real numbers with imaginary. So check this out. I'm going to write a complex number. All right. So let's see. Let me get my pen going. Here it is. All right. Complex number. Let me think of a real number. I wonder what number I'm going to choose. Oh, 23, Michael Jordan. All right. Plus, I'm going to take an imaginary and I'm going to say positive 9i. Could I have used negative 9i? Yes. This is a complex number. What's so special about this? That it has a what? A real number and an imaginary number. Let me write another one. How about negative 5? That's my real number. And then minus 2i. Is that a complex? Yes, because it's got a real and an imaginary. So with that said, I want you to write 2 more complex numbers of your own. 2 more complex numbers of your own. All right. Share with your neighbor what you got. See if they have something similar. 2 more complex numbers. You're like, oh, I think I got this. So yeah, we got this. So once again, a real number with an imaginary number make a what? Complex numbers. And guess what, guys? What you guys carry every day that you're always swiping around, your cell phones, mobile devices, iWatches, and everything that utilizes energy uses complex numbers. That's how we translate energy into that. This year, I'm going to show you some activities as to how we're going to translate some electronic stuff into numbers. You're like, what? Yeah. And this is just, like I said, a quick intro to there, okay? So from 1 to 5, how comfortable are you with real, imaginary, and complex? Yeah, 4, 5, 4, 5, yeah. All right. So now that I walked you all the way there, all of these are numbers, yes? Okay? Except for the last one and those over there because they have an I. Now, let's distinguish what we're looking at. Look up, please. We covered additive inverse because that's called 0 pairs. And I use that to find sums because we were able to do the addition and subtraction and combine like terms. Now, numerical expressions are these. 3 plus 5, 3 times 5, 3 divided by 5, and 3 minus 5. What do you guys notice? That it has what? Numbers. What else does it have? Operations, yes? So what doesn't it have? It doesn't have variables. It doesn't have variables. Numerical expressions are only numbers with operations. Once we add a variable, they're no longer numerical expressions. So what are they, Mr. Q? Well, those are what we call algebraic expressions. So let's go to our Freire model. We're almost done. So in your Freire model, algebraic expressions, write that, the definition, please. Definition, expressions that contain variables, numbers, and operations. And the numbers by themselves are known as constants. Expressions that contain variables, numbers, and operations. What's another name for numbers? Constants. Repeat that again. Algebraic expressions are expressions that contain variables, numbers, and operations. Examples? We got x plus 3, m minus 7, 2 times y, k divided by 5. Non-examples. Look at those. Look up really quick. Tell your neighbor why these are not algebraic expressions. Look at these and look at these. Why are those not algebraic expressions? All right, who saw the obvious? Hold on, before we leave. What do you guys notice on these? These have what? Equal signs and inequalities. That means these are solvable. Expressions cannot be solved. All right, we'll stop right there, guys. Your home play for tonight, it was only 6 problems. Have a good one, guys. Enjoy your lunch. See you guys tomorrow. Bye.